and welcome to this lecture. So in the previous lecture we implemented our coin.py where we implemented this important method for spinning. So basically when this rect.bottom, so if the bottom width is basically initial height is greater than that initial height, that means you just scale that because Mario has extracted or just has reached out to that coin. So you have to just scale that and just score should be appended. So this score should be implemented in the next lecture, but in this lecture we'll just implement the next component, and this is the important component and this is the brick. So let me create a new Python file as name bricks.py, and in this brick let me just import some of the module again. That should be import pygame module first is pg, and next thing what we're going to import is import from this data, just let me say from, so it should be from data is referencing to the data, and import means setup. So after that we'll just import some of other important module, and that would be constant is import me as c, and next thing will be importing the power-ups. So let me say import power-ups, and the next thing would be from this component you have to import coin. So one dot is for this component directory, two dot is for this data, so it should be power-ups, so it should be here power-ups. So let me see, yes, it should be power-ups. So next thing what you're gonna do is we'll just create a class here, and that should be bricks, and let me just give here as sprite in order to handle with the images, and bricks that can be destroyed basically. So in this class we'll just implement the bricks that must be destroyed when basically player just hit that bricks. So let's define as always the initializer. First part would be the initializer and containing a bunch of attribute here, that is x, y, and let me say contents, and the next will be power up group. So this should be power up and group, and last will be name. So name is obviously the bricks, so name would be brick, the power up group would be none in this case, that is a default value, and contents will be also none, and we have self x and y. So let's initialize the object. So first that we'll just initialize this sprite module here, so that would be from this sprite, and just call this init function of that sprite, and that should be like here, just call this sprite here and just pass the current object, that should be self. And next thing what you're gonna do is we'll just call that sprite sheet now, that should be just loading that gfx, and let me just create as usual this sprite sheet variable, and just use this set of module in order to load that gfx, and give the name of a gfx as tile set. So if you go here and just open this tile set, you can see the bricks, and you can also see here something, this is a pipe here, and similarly we have a bricks, and we also have here coin and bricks here. So let's use that bricks here. So we have just imported that is sprite sheet here. So the next thing will be just setting these frames for these bricks, so that should be empty at first, and similarly the frame index to work with this every frame, so it should be initially O, and just call this setup frame method, and this setup frame method would be now have to be implemented. So next thing what you're gonna do is call this image as in self dot frames, and it should be frames here, and just give here frame index. That should be self dot frame index here. So image has been initialized. Now get that rect out of that image. So that should be from get rect function. Just call this image and call this get rect function. So after that, let me just assign that is rect of the current x coordinate as that of this x position, and similarly this we should also have something that is rect y, and that should be obviously the y position, that is previous y position. So next thing would be just masking that surface. That would be something like self dot, let me just make marks variable. So this will just marks from the basically pygame module. So we have something that is marks from surface edge. Marks from surface give just a surface name, and threshold will be default as 127. So let me just define here, or just put a self dot image, which will be our surface. So next thing will be self dot bumped up. So this is basically when you just bumped up in the brick, should be initially false. And self dot rest height. So this rest height should be, as the name suggests, this should be obviously y at the first, and let me say here the rest height. So next thing what you're gonna do is we'll just make the state now. So the state should be, because this is a brick, so it should be resting state. So after that we'll just assign this y velocity, because this is resting, so there won't be any y velocity, and just give a gravity now. So gravity would be somewhere that is 1.2, and just give the name, that would be the brick here. And next thing what you're gonna do is we'll set the content now. Self dot contents should be contents that we passed here. And next thing what you're gonna do here is we'll say that is self dot group. So this group is basically for our power up group. So this should be power up groups, and let's put this power up in box. That means we'll just create this power up in box attribute, and that should be true. So we have defined the initializer, which contains a bunch of attributes here, and these are basically contents. And we also have something that is here, that is gravity, assigning the y velocity, and the state would be obviously resting state. So next thing what you're gonna do is we'll just get the image, and for that we just go in this coin, and you can see we have this get image function here. So this will be exactly the same as previous. So let me just grab that and let me just put it here. So basically it is also getting the image with this width and height, and just converting it to the bit mask, and just getting the rectangle out of it and bleeding that, and setting the color key, that would be obviously black here, and just this transformation should be done here, and just return the image that we transformed from this get image function. So let's define another function, and that would be, if you see here, that would be set of frames. So this set of frame should basically set of frame in the list. So we have to implement a list here, and in that list we'll just add our frame. So let me say that is self dot frame. So in order to add in this list we have to use this append, and what you should append is the two type of images of the box. That is one at position, so that is 8, 16 and 0. Get me width as 16, height as 16, and let me just copy all of this and just paste it out here. So we have only these two type of image for the bricks, and the first image has been initialized here. The next will be appended of that position, that is 432, and here could be and 16 and 16. So now we have just implemented this set of frame in order to add these frames to the list. So next thing what we're going to do is we'll just define the set of contents. So what this content basically is the quantity of the coins in our bricks. So that means we'll just say contents here. So this contents will be number, and this is basically containing the number of coins basically. And if we say that if self dot contents, so this basically was here, and basically if you see in this initializer, we just, it should be init not int. And in this initializer, if you see that we have contents here, and in this contents we have here contents. So this contents would be something that is of string type, and it will see, if you just see this content, it would be something like this, that is 6 coins or 12 coins. That is basically the contents of our bricks. So if it is 6 coins, what are you going to do? We'll just say that is self dot coin total. Coin total should be equal to 6. Else if it is empty, what you're going to do is coin total would be O. So every bricks contain a 6 content of coins here. So let me define another function in order to update, and that would be here update function, and it will only take this current object, and we'll just call here something that is handle state function. So it will just handle our current state. So call this handle state function, and that should be implemented here. And let's call, or just let's make this function now. That should be here handle state function. So this should be handle state, and just to make this as an current object, just put in the parenthesis. And this handle state basically determines the brick behavior based on the state. So it only determines the bricks behavior. So we'll say if the state, so based on the state it will determine the brick behavior. So I'll say if self dot state, that means we'll make use of this self dot state here, that is the current object state. And if it is resting, then what are you going to do? We'll just call another function here, that would be self dot resting again, and this should also be implemented. And elif, what is if it is the state that is bumped? That means if it is bumped, what are you going to do? We'll just call this bumped method again, and next will be if it is opened. So what if this brick is opened? That means just check here that is opened, then we'll just implement another method that is open here. Let me say opened. So it's time to create these 3 functions. So we'll just start with this resting function first. So define this resting function within self, and this basically is the state while you are not moving. So that means we'll say just the contents, we'll just deal with the content here. So if it is contents equal to 6 coins, because this means there is something in the bricks, this is not empty. And we'll check again if there is total, that means if the coin, that is self dot coin total, is equal O, that means it is already opened. So state now should be c dot, let me just open it, that should be c dot opened. So next thing what you're gonna do after this will be just implement another method, that is our bumped method, and let's do that. So it should be c dot c opened, and let's define that bumped method, and it should be bumped, and it will also take this self, and this is the action during the bumped state. So first to do that, we'll just rect should be extracted as y, and in this y we'll have the effect as in velocity. So that means we'll make this velocity to be increased in y, and similarly in the y direction there is a gravity. So we'll say that y velocity should also account something that is gravity here. So after this, we'll just check this velocity now. If this self.rect.velocity, that should be rect.y, not velocity, if it is greater or equal to something, that is, we have self.rest height here. If it is rest height plus 5, then what you're gonna do is we'll just add this self.rest height again to the rest height. That means just decrease that rest height of this rect and make it to something that is self.rest height. That would be defined in this initializer. You can see here that is the y basically. And now what we're gonna do here is we'll just say something that is, if the content is other than the coin, it can be star, it can be also the coins, and if it is it can be also nothing. So we'll just check for that. So we'll say if the self.content, and if it is content equal to star. So if it is star, so what you're gonna do is we'll say self.state again should be opened, that is c.opened, and we'll check if again that is self.contents here is 6 coins. So if it is 6 coins, what you're gonna do is we'll also say that is, we'll also check further, that is if the coin total is equal or not. So if coins total is equal to 0, that means we'll just make state again, that is the box is opened, and the next thing will be after this box is opened, we'll say if the coin is greater than 0, that means that box is not opened. That should be in this resting state. And in else part, that is if the content is neither star nor 6 coin, that means we have self.state should be now resting here, c.resting, and this will be our bumped. Now next will be our basically working with something that is we have here. Let me go up and see. The next function would be opened function. So let's create it now. So let's define it outside this bumped scope, and that should be as opened, and the argument will be self, and this is the action during our opened state. So we'll just check for the frame index first. If the frame index is equal to 1, that means what you're gonna do is we'll say that is self.image, so that get the image that is of this frame index 1. So if you see in this frame index, we have just created a list which has appended in these frames, and that image should be that is self.frame. So get that frames image based on this frame index. So that should be self.frame index. So after we get image, we'll now check basically for the contents. So that should be here if self.content, let me just put here I, and if the content, so what the contents of the bricks can be, it can be star, and if it is self.power up, so in the power up box we can have something that is mushroom or anything else. So what you're gonna do, we'll just add that in the group. So just add it, and that can be power ups dot star, and in that star let me just self dot rect and just give here center x, and similarly give this self dot rest now rest height. So this rest height is basically y, and this self dot rect dot center x, if you see here we have created that center x in this function that was somewhere here, and this center x would be the x position that is of the previous rect, and similarly this rest height is y. So we have just added this star. So if you just wonder what this power up is, so you just go to this power up and search for this star here. So this class power up, you can see mushroom class, you can see star now. So in this star, we'll just add this x and y, and default name will be star. So in the brick, we have just now added this star. So what you're gonna do next is we'll set this now power up in the box to be false. That is, just go here, and after we just added to the power group, we'll say that is power up in the box should be now false. That is rolling it back to its original value. So this will be our brick.py. So in the next lecture, we will implement this score.py, and we'll just work with this level1.py. We'll just call all of these enemy, coin, and bricks, and just will use this collider.py to work with it, and we'll just implement it on our game, and we will look if it really works. So see you in the next.